So we're going to put everything together, and let's draw this function using transformation. So go ahead and pause this video. First find your parent graph, then describe the transformations, and then draw each transformation and make a summary. So I hope you have done that. So you know that the parent graph will be y equals 1/3 to the x, just the number raised to x, okay, 1/3 to the x. And then let's draw that parent graph, okay. So I hope you know the points will be, when x is 1, it's 1/3, when x is 0, okay. So you can also make a table if you like, but there is so much pattern there that you don't really need to. So when x is 1, 0, and -1. So you know when x is 1, it will always be the base. So 1/3, it will always be 1. This will always be 0, 1. And then you just get the reciprocal of that, okay? So those are your 3 points. So let's describe. So let's draw that parent graph here, okay. So let's draw that here. So when x is 1, y is 1/3 here. When x is 0, y is 1. And when x is -1, 3. So this is our parent graph, and of course there is an asymptote here. Okay, anyway, let me just show you the transformations there. So when you graph that, just make sure that the reader can see your asymptote, okay. So there will never be 0 or negative values, so you have an asymptote there. So this is going to be your parent graph, approaching that line and going up here. So it's an exponential decay. It's an exponential decay. So I hope these are your transformations. Translate. Okay, so let's start with the exponent, 4 units to the right. PEMDAS, we're following PEMDAS, so exponents comes first. Then multiplication, there is an invisible -1 there. So that will be reflect across the x-axis, and this -5 here will translate 5 units down. So let's start doing all these transformations one by one until we reach our final graph. So first we're going to translate these 4 units to the right. So we're going to move all these 3 points 4 units to the right. So 1, 2, 3, 4. We're here on this 1/3. 1, 2, 3, 4. 1, 2, 3, 4. Wait, I counted this wrong. 1, 2, 3, 4. It should be here. Okay, so next, 1, 2, 3, 4. Okay, so this is our first transformation. You use broken dashes or dashes as we always do. Our asymptote is still there because if you move this line 4 units to the right, it's still the same line. It's infinite. So okay, next we're going to, so this is now the graph of y equals 1/3 x, and this is now the graph of 1/3 x to the -4. Okay, now we're going to next reflect across the x-axis. So we're going to reflect across here. So that's 1/3 will be here, that 1 will be here, and the 3 will be here. So this is now a reflection. Okay, our asymptote is still there. So this is now the graph y equals 1/3, y equals -1/3. Okay, because we reflected this. So -1/3 x minus 4. Okay, next we're going to translate this. Oh, wait. So it's here. Okay, so 1/3, 1/3, 1, 1, 1, 2, 3, 1, 2, 3. Okay, these are 3 points that we're going now to translate 5 units down, and that's our final graph. So let's use red. So when we translate this 5 units down. That's a lot. Let's move our paper so we can reach 5 units down. So that 1/3 is 1/3 here. That's 1, that's 2, 3, 4, and 5. We're here. Okay, and then this one will be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So let's use red on, of course. Let's not forget to move also our asymptote 5 units. We also move our asymptote. Okay, asymptote is part of the graph. So 1, 2, 3, 4, 5. Let's use red. So this is now our asymptote. It also move 5 units down. So that is now the line y equals -5. Okay, so this is our final graph here. You can see. Okay, so let's start doing our summary. So this is now the graph. Y is equal to -1/3 x minus 4, then minus 5. Okay, so it's now an exponential growth. Okay, it's going up. We started with a decay, but then you reflected it, so it becomes growth. It's now an exponential growth. Our domain is all real numbers. Range is -infinity to -5. We stop at -5. Okay, and then we say that asymptote is now y equals -5. The line y equals -5. Our x-intercept is none. We're not going to hit the x-axis here. None. Y-intercept. Okay, this one, can we see our y? Will there be a y-intercept? Okay, so it's, if we continue this line, it's going to somehow hit this, going to continue this graph. We're going to hit this line somewhere along the space. So if you cannot see it, then you have to calculate your y-intercept. How do you find your y-intercept? Make x equals 0 in the equation, so y equals -1/3 raised to 0 minus 4 minus 5. Okay, so let's calculate this. So negative, let's do first 1/3 to the -4. What's 1/3 to the -4? I hope you know that is 81. Okay, try to use your knowledge of exponents. Okay, so that's -81 minus 5, it's -86. So when we hit -86 here, we're going to hit that one, hit the y-axis. Okay, so that is how you graph with all the transformations. I hope you got that.